Today we'll be testing the bolt's ability to auto-correct an improper hookup. New with the bolt is the ability for the bolt to sense if CTs are backwards or if the phases are swapped. So this allows you to fix a backward CT or mismatch between voltage and current phases without having to reach back into an energized environment and change those connections. It can be confusing in a CT cabinet or in an enclosure where it's not really clear which is phase A, B, and C, or which way is points towards the load or away from the load. So to allow for those after the fact corrections, the bolt has the ability during the 2-minute countdown to sense potential miswiring or misconfiguration, and it allows you the option of fixing that. It can do this for you. It can swap CTs, can invert a CT, roll the phases if the phasing doesn't match the voltage, and all these are done automatically. And I'll show how this works, and also show that it is working. This is a test of the bolt's ability to auto sense these common hookup errors and fix this for you automatically. So with this test, we're going to test the bolt's ability to fix a hookup automatically without any user intervention. So in this situation, we're say initializing the bolt in the office. I'm going to use PMI view on the iPad app to connect to the bolt. I'm just powering it up through its USB-C connection, connect to the bolt, and I'm going to start a new recording. And I'm going to make sure I have phase correction turned on. This allows the bolt to automatically fix any sort of detected hookup problem. Send these to the bolt. Now the bolt is initialized, it's ready to go out in the field, and we'll do that in our lab to make sure it can fix a hookup mistake. So let's take the bolt to the lab and let it count down and let it record. So we're in the lab and we are going to connect the bolt to our test circuit. I've got voltage connected here with a 3-phase power supply with A, B, and C voltage, and I have my CTs. Now I have orange, red, and yellow for A, B, and C, and I'm going to intentionally reverse one CT so that channel 3 is backwards, and I'm going to swap A and B. So the CTs are hooked up incorrectly. We're going to let the bolt power up, go through its countdown, and start recording. So I connect the CTs to the bolt. The bolt will go through its countdown. During that time, it will auto-detect the misconnection and fix this for us because I've got that enabled in the configuration. So let's let the bolt count down, let it record. We'll take it back to the office, download it, and confirm that it automatically corrected the hookup. So the bolt's been recording. Let's take it back to the office and download the data and see if it was able to correct this hookup problem. All right, we're back in the office and we've got the bolt powered through its USB-C connector. We're going to use PMI view on the iPad to download this bolt. So I'll connect to the bolt. So we've connected to the bolt with PMI view, and let's download the recording. So I've downloaded the recording, and now I'm going to transfer it to PQ Canvas in the cloud to take a look at the data. So we're in PQ Canvas, and we'll pull up the recording for this test. Look at one of the waveforms so we can see they're all in phase. Look at the vector diagram, and we have phase A, B, and C voltage and phase A, B, and C current all in phase. The bolt has made automatic corrections to fix this hookup. We can also check the corrections the bolt has made. The hookup adjustment in the header report allows us to view what's been done. So it's inverted channel 3 phase C current, and it's swapped A and B. So we have the corrections that it's done. We have the corrections that it's made in the data file, so we can go back and see what was done to fix this hookup. And indeed, the data in this recording is correct. The bolt has successfully automatically adjusted the hookup without any user intervention out in the field. Now we're going to check the bolt's ability to make corrections with flexible CTs instead of the iron core CTs. These are the Bolt 9-inch CTs, the Rossi Cool style CTs, and I've just kind of hooked them up randomly. I didn't pay attention to the arrow on the CT or which channel goes with which phase. And as you can see from the vector diagram here in PQ Canvas, so there are a lot of mistakes in the CTs. I basically got everything wrong. Let's see if the bolt can identify this and automatically fix it. So the bolt's beginning its 2-minute countdown. You can see the LEDs are in the countdown state, and it's telling us to check the hookup. As you can see, there are a lot of things wrong with my hookup. It wants me to switch channels 2 and 3, switch channel 3 to channel 1, basically roll the whole CTs and swap 2 of the CTs. So I've made a lot of mistakes with this hookup, but that's okay. Let's check the bolt's ability to fix this for us. So the bolt has finished its 2-minute countdown. It's begun its recording, and it's applied the fixes that it detected that it needed. The error message has gone away to check the hookup. Let's check the vector diagram, and now we see we have 3 phases of voltage current. The current phasors are in line with the voltage, and ABC volt current matches ABC current. It has applied all the corrections needed to fix the rolled CTs and inverted CTs. So we've seen that the bolt can identify the common hookup errors with flip CTs, mismatched phases and channels on the CTs, and apply these. They can warn you about that. You have a chance to fix it yourself, or it can let the bolt do it for you. So the bolt's passed the test. It can identify these common mistakes and fix them for you.